Hello everyone, I am Prem Deep, a student of Engineering Physics IIT Roorkee. Today I am going to demonstrate an experiment which is potentiometric error detector. So let's go to the lab. So the objective of the experiment is to study potentiometer as an error detector. So before performing experiment, let's have a look on the apparatus that will be required for the experiment. So there are basically three things that will be required. The first thing is a potentiometer error detector kit, and the second is some connecting wires to make the proper connection, and third is a CRO. So let's have a look on potentiometric error detector kit. As you can see here, there are two potentiometer, part 1 and part 2, the resistance of which can be changed by rotating this knob like this. And this experiment can be performed both for AC excitation as well as DC excitation, and we can change the excitation with the help of this switch. Also there is a voltmeter display which basically shows the voltage corresponding to the angular position error, and this is the connecting wire which will be used for connections, and this is CRO which will be used only in the case of AC excitations. Now let's switch on the setup to perform the experiment. So what we are basically going to do is we will set part 2 as reference shaft, and then we will rotate part 1 shaft to get different angular position error, and then we will make a reading table of angular position error and the corresponding voltage output, and then we will plot this data on a graph paper and see how this angular position error varies with respect to output voltage. Since firstly I am going to perform the experiment for DC excitation, I have adjusted this to DC, and I have already made the proper connections as you can see here. Now let's set the reference shaft to 180 degree, and we will adjust the control shaft from 10 degree with a step of 20 degree. Now if you want to calculate the angular position error, then it is 180 degree minus 10 degree, which is 170 degree, and the corresponding voltage output is that is coming here is 2.38 volt. And I have write down this reading on the reading table. Again I have adjusted this to 30 degree for a angular position error of 150 degree, and the corresponding voltage output coming here is 2.09 volt, and we note down the readings. Now we will keep doing it till the time we come to the position from where we have started, that is 10 degree. Now we are having this reading table for DC excitation, and here are the value of part 1 position theta 1, which is in degree, and you must be aware that the part 2 were fixed at 180 degree. So here I have written this, and This is the angular position error theta e, which is basically theta 2 minus theta 1, and this is the corresponding output voltage. So now we will plot the graph between angular position error and the corresponding output voltage with the help of this table. So let's do that. So here is the graph that I have plotted with the help of that table between the angular position error and the corresponding output voltage. So from this graph it is very much clear that it is coming as a straight line, which means that the output voltage is proportional to the displacement. So we can express this as V node is equal to Ke times theta e, where V node is the corresponding output, Ke is actually the error detection coefficient, and theta is the error. Now this error detection coefficient can also be calculated, which will be basically the slope of this graph. So here I have calculated the error detection coefficient, and it is coming as 0.014 volt per degree.